Hello! In this video we're talking about factoring special cases. Those special cases are perfect square trinomials, difference of two squares, and sum and difference of cubes. Let's jump into it. First up are perfect square trinomials. This is straight from your formula chart, so you do not have to memorize these formulas. But it's anything of the form a squared plus 2ab, or maybe minus 2ab, plus b squared. They can factor down to a plus b squared or a minus b squared. And this minus tells us this minus is right here. If you're wondering what this a squared and b squared are, they're simply perfect squares. Numbers like 4, 9, 16, things like that. Let's see one example. To help us with these next few problems, I've provided a table of perfect squares. Okay. So whenever I'm looking at this problem, factor 9x squared minus 30x plus 25. And for perfect square trinomials, I have a perfect square in the front, a perfect square in the back. This is a perfect square. This is a perfect square. I'm thinking that it might fit this pattern. I'm thinking that it will probably fit the pattern a squared minus 2ab plus b squared. So I need to figure out what is a and what is b equal. To find a, I have to think, what got squared to give me 9x squared? Well, that would be 3x. And that's just because 3x squared is equal to 9x squared, which was given as that a squared. Now, on this back side, that's a little bit easier. What got squared to give me 25? Well, that's just 5. Now, to really check myself, I need to plug in these numbers that I just got for a and b into negative 2ab to make sure that it's negative 30x. So that'd be negative 2 times 3x times 5. Negative 2 times 3x is negative 6x times 5 is negative 30x. So everything checks out. So I can see that this is following the pattern a squared minus 2ab plus b squared. It all factors down to just a minus b squared. So all of this should factor down to just 3x minus 5 squared. All right, here you go. You give it a try, knowing that this is a perfect square and this is a perfect square. And start by just finding what's a and what's b. After noticing the pattern is a squared plus 2ab plus b squared, we should get a is equal to 4x and b is equal to 1. Now checking 2ab, 2 times 4x is 8x times 1 is 8x. So this factors down to 4x plus 1 quantity squared. All right, the next that we see all the time is the difference of two squares. A squared minus b squared equals a minus b times a plus b. Basically, what you're looking out for is a perfect square minus a perfect square. It'll always break down into the roots of each of these squares, plus and minus each other. So here we have 49x squared minus 81y squared. I can take the square root of both of these, and there's a minus sign in between. So this is of the form a squared minus b squared. So a, what was squared to give me 49x squared? That'd be 7x. And what was squared to give me 81y squared? Be 9y. So now that I've found the roots of each of these, this all factors down to 7x plus 9y times 7x minus 9y. You go ahead and give it a try with x squared minus 100. Well, what was squared to give me x squared? Simply x. And 10 was squared to give me 100. So this factors down to x plus 10 times x minus 10. Finally, we have the sum and difference of cubes. These can be challenging for people because not everyone knows all their perfect cubes. What you need to remember while you're just plugging in a and b into this side of the formula is that if it's a sum, we have plus then minus. And if it's difference for this minus, it's minus then plus. All right, so let's look at x to the 6th minus 125y cubed. And now I've provided you with a list of perfect cubes. All right, so if this is of the form a cubed minus b cubed, we know that this could all factor down to just a minus b times a squared plus ab plus b squared. But what's difficult here is figuring out what got cubed to give me x to the 6th. Well, x to the 6th is the same thing as x squared cubed. So then minus. What got cubed to give me 125y cubed? Well, the cube root of 125 is 5. So this is the same thing as 5. The cube root of y cubed is just y cubed. So a was equal to x squared, and b was equal to 5y. Now it's just a matter of plugging in a and b into the formula. So I'm going to start by not even squaring these terms, but just writing anywhere I see an a, I'm going to put an x squared, and anywhere I see a b, I'll put a 5y. As we can see here. Now I'm going to go through and square these two terms and multiply these two, so that I finally end up at x squared minus 5y times x to the 4th plus 5x squared y plus 25y squared. And this is the factored version.